Hey everybody, this is Larry. This is, I don't know, day 29 of the Leetcode Daily Challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about today's poem. Today we have another part 1, so hopefully, I don't know, we don't have part 2 tomorrow because these are kind of just getting lame in the way that it's set up. But yeah, I ran a little bit today, but I was running for speed, so I am like very tired. Instead of slow and zone 2, today I've been running for speed, but not even that fast because I'm running at basically my marathon training pace from last year, but for like 2 miles and then I was just done. But I think some of it is that I was on a treadmill, and on the treadmill, I don't know, it just gets so boring. I have to run outside. That's my story and I'm sticking to it. But yeah, without further ado, because I do feel like I'm so tired, let's take a look at today's problem and let's attack it. All right, you have source and target, length n, lowercase letters, 0 index characters, original and changed, and a cost of I is the cost of changing original to the character changed. You start with the source, so you pick X to change to Y, and then you get the cost of Z. Okay, so basically, I'm sorry, I'm reading this and I'm trying to understand what it means. Oh, so basically there are multiple things. Okay. Or like, what's it called? Multiple edges between two nodes, right? So the first thing to know about these particular problems is just that, you got to treat the nodes of this graph is the alphabets, right? You're going from A to B and B to C and so forth. And the tricky part about this one seems like is that, and I don't know if they mentioned it, I don't think they mentioned it explicitly, but maybe in the samples, that's why, is that like if you want to go from A to, or maybe in this case, D to E, maybe it's cheaper to go from D to A and then A to E or something like that, right? So then you have to get that cost. But overall, it's pretty straightforward. There are two ideas or algorithms that you can use for this. Either is fine. One is, of course, all pairs shortest path, which is honestly, in this one would just be single source shortest path, but with a loop, right? You just do it for every node, and then just BFS, or not even BFS. Sorry, you just do like you could use Dijkstra. You can use what is the other one I'm thinking of? I don't remember anymore. The one with the for loops. I mean, I'm not talking about Floyd Warshaw, because the other thing that you can do is Floyd Warshaw. But there's like a shortest path one with, okay, never mind. It's not that important because there's no negative edges or cycles anyway. I'm just blanking out on the names. It's been a while. All right, so so the first thing that we want to do is we just, I'm going to do it to Floyd Warshaw, right? Because I love Floyd Warshaw. It's one of the first things that I remember learning as a kid, or as an engineering kid, if you want to call it that. I was old at the time, but it's just like, wow, doing 3 for loops can be magical, And I never really understood it. Well, I mean, like at that time. Eventually I did, but yeah. Let's say A for alphabet, right? Right, so something like this, and then I assume you just write something like just because, in this case, technically you just not change, right? I think that's the takeaway. But yeah, and then now we parse the thing, right? So maybe we go for XY because that's what they use for original and changed. In change, oh no, you have to in zip of original, changed, and cost, right? So I missed cost, but that's okay. And then here is just pretty straightforward, right? Maybe maybe I call it XC and YC for the alphabet, and then X is just equal to right? So then we map this from the character to 0 to 25, inclusive. And then we can just write distance of xy is equal to c, right? I'm just checking to see whether you can go backwards. I don't imagine in the wording that they did that you can, but just double checking because you never know, right? And then now that's it, right? Then now for source and target for 6y, we'll use the same thing, right? For source target, we'll even copy and paste here, though maybe that's a little, you can be a little bit cleaner. We have a total for the total cost, and then yeah, we just add it by distance xy. Oh, well, I mean, that's not quite right because we didn't actually do the shortest path part, the Floyd Warshaw part, right? So then this is Floyd Warshaw, right? And this is you could say this is a dynamic programming thing. This is after with K changes, if you will. But, people usually drop the last dimension. Math? I just write math. What are you doing, Larry? Min, right? Yeah. Oh, that means that is impossible. I didn't know that there were impossible things in here, that's all. But that's just obvious, right? Oops. I should really read the problem more. But yeah, so this is gonna be, where's the, wrong answer, huh? Oh, is there a mod that I forgot? Am I just confused? Huh. Wow. These days I am like getting owned by a silly problem. Why? How? What? Oh, I am dumb. I'm dumb. I have this. I mean, I even pointed out. That's why I remembered it. Is that you have to take the min, right? Because they even have a line that said you can have multi edges, and I even pointed it out. But then I just kind of, I don't know, I forgot because I was watching, I suppose. Where is this? Whoops, what a dumb. I even noticed it and then I forgot it. So what's the complex these days? Yeah, thanks. This is a cube, right? But everything else is linear except for a cube. And technically this is L, or not this. This is L, where L is the length of this thing. I don't know what value they use, but yeah, let's just say that's L. Then yeah, so then this is going to be L plus a cube plus, I don't know, T for, I don't know, whatever, right? So a lot of linear things, right? Linear alpha cube, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.